You order dinner on your phone, you tap place order, and then nothing. The spinner just turns and turns. Somewhere, a person whose whole job is to fix this is about to go hunting for the reason. Before we follow them, guess at two things for me. First, a company like the one behind that app pays real money for a whole separate piece of software whose only job is to sit and watch its own software. Why would anyone need that? Second, and we settle this one first, to find why your order is stuck. How many separate computers does that person have to look inside? Pick a real number and hold on to it. If you pictured a single computer in a building running the app, someone opening it up to see what jammed, that is the natural guess. It is what almost everyone pictures. It is also about to be spectacularly wrong, and watching why is the whole trip. For most of the history of software, that guess would have been dead, right? One app meant one program running on one computer that we call a server. And a server, it is really just a computer. No screen, no keyboard bolted to a rack somewhere, but a computer when the app got slow, someone logged into that one machine, the way you'd log into your laptop, and looked around. They read its diary, the running record every program keeps of what it just did. They watched how hard it was working. There was one place to look, and if the answer existed anywhere, it was in there. So hold that picture, because from here we start taking it apart, one piece at a time. And every piece we add makes that quiet little server harder to find. Watch what happens when the thing grows. Your app catches on more people, more orders, every second. The first wall is physical. One computer has only so much muscle and memory. Push enough people through it, and it runs out of room. The way one stove in one kitchen can only cook so many dinners at once. The second wall is people. If everything you sell lives in one giant program, every engineer is elbow to elbow inside that same program. Someone tweaks the checkout, and the search bar falls over. One small mistake takes down all of it. And the third, maybe only the checkout is drowning on Friday night, but you can't pour extra muscle into just the checkout. It is welded to everything else. You grow all of it or none of it. So companies did the obvious thing. They chopped the one giant program into pieces. Checkout became its own little program. Search, its own payments. Sign in, saved addresses. Each broke off into a small service that does one job and nothing else. And this is not a little chopping. Load one page on Amazon, and more than 100 of these services light up behind it to build what you see. A company like Uber runs a couple thousand. Wait, more pieces. That just sounds like more stuff that breaks, more to keep track of. You are right, it is. Hold on to that objection. It comes due later, and it turns out to be the whole reason this video exists. But first, the pieces buy us something we badly need. Now we've got a swarm of little programs instead of one big one, and that raises a dull but urgent question. Where does each one actually run, and how do you move it around without it falling apart? Because a program is fussy, it needs the exact right versions of 100 helper tools around it, or it won't start. You've felt a tiny version of this, an app that runs fine on a friend's phone and crashes on yours. The fix is called a container. You take your little service and pack it into one standard box, and into that box you seal every single thing it needs to run. Its helper tools, its settings, all of it. It carries its whole world with it. Now, it doesn't matter whose computer you set it on. The box brought everything, so it runs the same everywhere. And since it is just a sealed wrapper around a program, you can start a fresh one in about a second. Hang on. A box carrying its whole world. Isn't that just a tiny computer inside my computer? That is the most common mix-up here. So let's kill it now. A tiny computer inside your computer is a real thing. We call it a virtual machine, but it hauls an entire second operating system around. So it is heavy and takes minutes to boot. A container skips that weight. It borrows the operating system of the computer it is already on and packs only your program. So it is light instead of heavy. And it starts in a second instead of a minute. And they got light enough that in 2014, Google said that across everything they run, they start over 2 billion of these containers every week. And I do mean a week, not a year. Quick gut check. Someone swears a container is basically a whole virtual computer, right? Half right or wrong. Wrong. And you know why now. A container was invented to avoid dragging a second computer around. It borrows the one that is already there. Before the last big piece, let's put faces to names, because they move fast. Now this is a service, one small program, one job. This is the container it rides in. And this is a node, which is just a fancy word for one of the actual computers in your fleet. You've now got hundreds of containers that need to land on some set of nodes. So picture that placement job, live. Every one of those containers has to be assigned to some machine. One of them crashes at 3 in the morning, and something has to notice and start it back up. A whole machine dies, and the dozen programs that were living on it need new homes immediately. Friday night hits, checkout gets slammed, and 10 more copies of just the checkout have to appear. Then disappear again when it goes quiet. So who is awake for all of that, every second, forever? Nobody is. So we hand the whole job to a piece of software, and that software is Kubernetes. And working with it is genuinely different from bossing a computer around step by step. You never tell Kubernetes how to do anything. You tell it what you want to be true and walk away. You say, keep 10 copies of checkout running always. From then on, it never stops checking. If one dies, it quietly starts another. If the machine underneath vanishes, it rebuilds those copies somewhere else. It is a thermostat for your whole fleet. You set the number, and it fights the world to keep reality matching it. But does Kubernetes fix my actual code? If the checkout is buggy, does it patch it? Number in that line matters. Kubernetes only cares how many copies are running, and whether the checkout itself is any good, whether it is fast, slow, or quietly wrong. It cannot see it all. And right now, neither can anyone else, which is the wall we've been walking toward. Every upgrade we just made quietly came with a charge. Let's add up the bill. The splitting, the boxing, the autopilot, every clever move did the same thing to us. Together they made the app almost impossible to see. Go back to your frozen order. That one tap doesn't reach one program anymore. It starts a relay race. Checkout calls payments. Payments calls the bank and the fraud check and your saved cards. Something calls the restaurant. Something calls the map for a driver. A dozen little services on a dozen machines, all touching your single tap. So that number you were holding to find why your order jammed, how many computers does someone open up? It was never one. It is every machine in that relay. And the fault hides in whichever handoff went wrong. That is your answer to the second thing I asked. It was never one place to look. It is dozens of them, scattered across the fleet. And it gets worse, almost funny. Say one little program did crash. You rush to log in and read its diary, but remember the autopilot. The instant it crashed, Kubernetes threw it away and started a clean one elsewhere. The thing you wanted to inspect is already gone. You can't open a box that no longer exists. Sit with how strange that is. We got exactly what we asked for. The app scales, heals itself, shrugs off machines dying overnight, and the price was a blindfold. The better it got, the less anyone could see it. If you can't walk over to the system and look, there is really only one move left. You make the system talk to you constantly. Every one of those little services on every machine sends out a running commentary of what it is doing while it does it, all flowing to one screen you can sit in front of. Every box grows a little wire, and the wires all run to the same place. That one screen where the whole invisible sprawl finally shows up in front of a human. For a huge number of companies, very likely including the one you use at work, that screen is a product called Datadog. And the timing tells you something. Datadog was built in 2010, years before Kubernetes even existed. So it wasn't invented to babysit Kubernetes. It was built for the older, deeper version of this problem. The people who write the software and the people who run it were staring at different information, talking past each other. The founding idea was to drag everyone's view onto one shared screen. The old way was watching a few dials. Is the machine hot? Is it low on memory? Fine for troubles you expect. But the misery of a system like this is the trouble you didn't expect for that one user. On that one order, to catch those, you want to ask the system a brand new question after the fact and get an answer. That ability even has a name: observability. And now the part that probably confuses you most at work: why there are so many different products crammed in there. The moment you see them as different ways of looking at the same invisible system, they stop being a grab bag. Think of it as a doctor's kit for your software. The infrastructure view watches the machines and containers, the fleet's pulse. The metrics are the vital signs: orders a second. How many failing? A trace follows one request through the whole relay and shows which handoff dragged, the one you'd open for the stuck order. The logs gather all those diaries into one searchable pile. And two look from the customer's side. One records what real people saw on their screen, and one sends a robot through your app every few minutes. So you catch a break before your customers do. So that very first thing I asked, why pay for a whole product just to watch your own software? Because once it became this sprawling, shape-shifting thing spread across a fleet you can't visit, watching it from outside through a stack of lenses stopped being a luxury. It is the only way to know what your own system is doing. Two quick limits. Datadog isn't magic or your only option. Free tools do slices of this, and in a pinch you can still poke around by hand. And the watching isn't free. Streaming all those signals is what you pay for. There are 20+ products and hundreds of ways to plug in, and almost nobody uses all of them. Most teams live in 3 or 4. One last gut check. The real thing you do at work. Check out slow, but only for some people. And you want the step that is dragging. Which lens first? The logs, a trace, or the little robot? The trace, it follows one order through every handoff and timestamps each step. So the slow one lights up. Logs would get you there, but you'd read 1,000 diaries doing it. And the robot's for catching a break before anyone's paged, not digging into a page you already got. One program got too big. We split it into many small services, boxed each to run anywhere, and gave the swarm an autopilot that made it powerful and impossible to watch. So we made it stream itself to one screen. And watch what those 5 steps spell. You split the app into services. You containerize the pieces. You orchestrate them with the autopilot. Then the problem, it is scattered and it won't hold still. So you put eyes on it from outside. Split, containerize, orchestrate problem. Eyes, that spells scope. And scope is exactly what you get back, your whole system, finally, where you can see it. So next time that tool at work throws 20 tabs at you, they aren't 20 random gadgets. Infrastructure is your machines. A trace follows one request. Logs are the diaries. The user views are what real people and little robots see. A handful of lenses pointed at one system that got too big to see any other way. So here is the one I'll leave you with. Next time something at work is slow and you go to open that screen, which lens are you reaching for first?